Is this working? Okay, welcome. Hello, hello. So, hello world. Hope that all is well. Welcome, welcome. Okay, so, oh boy. Whew. A few things I think talk about, go over quickly. What's the plan? Yeah, I got some things to talk about, updates, and yeah, we'll get right into programming here. I don't know if this is a bad habit, but I've been, was it 2 hours, 2.5 hours ago? Yeah, I got home around 2.5 hours ago. Thinking, yeah, it's a pretty good amount of time, 2.5 hours. I mean, I spent maybe half an hour eating, spent some time, used the bathroom, spent some time, yeah, no real excuse though. I mean, I do like to spend some time just kind of hanging out though. There are some folks I like to watch online. Let's check out, see what they're up to, watch some YouTube videos, listen to what people have to say. Some imparting of wisdom, let's say. Preachers and whatnot. So, I guess it's okay. Actually, I'm thinking about it. It's like, yeah, it's alright, take some time each day. Listen to what's going on in the world. Would have saved myself about $600 if I had listened. Actually, no, it would have been better than that. It would have saved 500 and made probably a few hundred if I had listened to my instincts. You know, I was paying attention to. I noticed that there was some news about something going on with Hong Kong and China, and then the stocks dropped dramatically after that. They're gonna go back relatively quickly, shortly, because it was really just, it's kind of like a flash pan type of thing where, I don't know what you call that. I don't even know that's the name of it, but I'm just, if you throw something that sparks into a small container, it's like you see a little bit of fire come up in like a metal container, but then it immediately dissipates. Sort of flash, I don't know what you call that, but like a flash fire type of thing. But yeah, that's what happens with the news. You know, the news, they kind of send everyone into a bit of a tizzy and scare everybody, and then some investors, the wiser ones, don't pull out their funds, but the less wise among us, they get kind of spooked, and then the stocks take a nosedive, which they did. A lot of people made a lot of money over the past few days because the stock dropped dramatically. The S&P took a huge downturn, and then it's been slowly coming back up. But like it'll go back to where it was relatively shortly, and I anticipate, because realistically, there's kind of, like I said, blue skies, clear skies. As far as the economy, things are looking up and up. I think they're going to go up, 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 up. But anyway, that's just my opinion, my view. But yeah, if I had paid attention to my own intuition, I knew that the news broke about that. There was another sort of scare about China and Hong Kong, and Trump signing a bill that would sort of twist the arm of China a little bit. But I bought anyway. Couldn't wait a couple days, so I just waited a couple days. But yeah, those kinds of why I'm bringing that up, those kinds of things are related to taking the time each day to just kind of see what's going on in the world. Listen to preachers, listen to the news, listen to just stuff on my sort of YouTube news feed. Sort of get enough of a view of geopolitics, because the feed that I get is the same feed that everyone else gets. And if I see CNN is just blasting everywhere, world war with China, it's like, I think the stock might take a hit. even if it's not even true, CNN or similar outlets have enough pull where they can influence stock because they can just tell people what the news is, true or false. Yeah, so I don't think it's wrong. I don't think it's bad. I think though maybe should be a little more aware of it than I am, because 2.5 hours is a lot of time. I guess. Yeah, updates on what's going on with me. I'll just throw this up here if anyone wants to read this while we're chatting. So we'll also update you on this problem too. I learned some more about this. So updates on me. I spoke to my employer about working remotely. Starting to get really focused now. I'm thinking, right, you gotta have a family, you gotta have children, you gotta do that. It's extremely important, and you must be done. And you gotta do it sooner than later. And right, what I was suggesting the other day was about like, oh yeah, because I don't have a wife, I take very big risks, and I've realized that over the past, like, I don't know, I guess maybe 10 years, I've just been taking these gigantic risks. Which I should bring that up. There's a fellow that I work with, a fellow employee who I chat with quite a bit when we have time, and sort of usually it's in the mornings before things really get going, and sometimes in the afternoon when things are sort of died down a bit. There's like certain periods of time where there's like a lot of activity and there's a little less activity, but when there's opportunities, we just kind of chat for a few minutes. And I should have mentioned that to him because he asked me about, because I mentioned to him that I kind of felt like I was floundering in my life for a while. And I could have brought that up to him, that I also suddenly realized that I've been taking gigantic risks. And even with my time, like I didn't fully appreciate the urgency of my time, in the sense of like, you need to have a family, you need to get this going, you need to get yourself secured. It just the things I decided to do with my time, the risk reward, like, okay, I kind of had this idea of like basically I was untethered with my choices, my decisions. Yeah, they weren't like tethered to like, the sense of urgency about my time, because and like they may not have necessarily been bad decisions inherently. It's just they're bad decisions if you take into account that you shouldn't be wasting your time, and in an extreme, like wasting your time, like it's not like, because there's in one sense is wasting your time, like, oh, going and doing drugs is a waste of time. Like, yeah, it's not just a waste of time, it also, like, you lose time doing that, right? Like, I wasn't doing things that were going to cost me time by like, like doing things that are illegal, or doing things that are like highly immoral, or doing things that are detrimental to my health and well-being and things of that nature. Maybe you could argue I got like addicted to video games, but like that's an example. Is video games, like, you lose a lot of time playing video games. That you got to have urgency, right? Like, your life, you're only going to get older and weaker over time, and you're only going to get like, opportunities are only going to pass you by over time. Like, that's, you gotta like set yourself up. You gotta pursue a family. You gotta do it. There's urgency, and the decisions that I was making, that they were sort of high risk and maybe not all that much reward, despite the risks. And even recently, in my trading, I traded on, I knew it was extremely risky, which, by the way, is highly ironic, because considering the nosedive that the market took the past few days, I think what I purchased, I got out of it, but what I had purchased would have expired, like, I think almost on the nosedive, and I would have made a lot of my money back. I was at no, I'm sorry, no, I wouldn't have made my money back. No, it ended up being too much. It ended up being a poor bet in the first place. But if I had made the same bet like 3 weeks ago, I would have cashed out. So it wasn't that off, but it was, I knew it would be really high risk, and kind of like toying around with different ideas that I had, some of them highly successful, some of them highly unsuccessful, also fit that category of like, I didn't really have a good sense of urgency about my time. Like I should not be toying around like this. I should have been, if I was going to toy around with a lot less money, basically. Although part of that is, it's kind of good that I lost a lot, because it's like it really hammered that home, that point of like, look, when someone, if you combine the place my mind was in after that with someone telling me, look, there's a certain issue with being single for a long time where you don't really tether your decisions to like the risk involved. It's like when those things were combined, I was like, I really saw it. Instead of these words falling on deaf ears, my ears were wide open. So it's sort of a good and negative thing, good and positive thing to consider there. But yeah, I could have mentioned to this gentleman, I could have asked him what he thought about that, because I forgot that was a really critical thing, like realizing that the urgency. So yeah, I spoke to my employer about working remotely, and my immediate manager said, look, probably not, because the job I work right now entails answering the phones, and it's kind of hard to do that remotely. So I said, okay, how about like, if I move to a different team, or actually he even offered, he's like, well, if you're on like implementation, maybe we could do it. I said, okay, well, maybe I can move to another team. And I mentioned to him like, well, look, I may need to find employment elsewhere. Like it's like really, really high priority for me right now is to consider like finding something that's remote. And the reason is that I'm thinking, look, I want to secure myself financially as much as I possibly can before I have kids and get married. And what I want to do is basically get some really cheap land, sort of in like Tennessee and the sort of, out west or where what have you, get some cheap land, work remotely, and build a small house on that land. And then it's cheap property taxes. It's to have the land. I could even start building out like around that time. I probably want to get married and have kids and have her move into the house that I build, and then and like start kind of farming, I guess. Not a lot, but enough where and start prepping, I guess, where like I could be sufficient. Not prepping too much, but just enough where like you'd have a few years. So in case something happened with my employment, I could not only farm the land itself, like where I'm established, like live off of that. So no one wouldn't actually need a job and could still survive comfortably. But also get myself in a position where if I lost my job, I'd have like 2 years at least with the family where I could figure it out. Could still kind of keep everything together. And on top of all of that, the kind of salary that I would pull. I mean, even right now, if I had kept exactly the same salary I'm at and moved out remotely, yeah, I mean, I'd be fine for a long time. I'd have all that I need. And I mean, we're talking like you could build, like for about $30,000, you could build a small cabin, 30 grand, 3 months. You could build a small living abode. The land might be like $10,000, so like $40,000 altogether. You can go out and build. That's it. I mean that and the rent I pay right now, it's a little bit lower because I'm splitting it with my family members, but it would be like $2,300 a month. So that's $24,000 a year. It's like, yeah, 2 years I could have a house and land and like, save 20 grand a year. That's really, it's really just the economics of it are such, and on top of it, I could probably get promoted where I'm at, and there's other details too that are important, like, the commute to my job is like kind of horrendous. It's like takes like 2 hours a day, 5 days a week. It's kind of brutal. And then also, the commute's kind of brutal. And what else is there? So I'd actually have those 10 hours a week. I mean, that's a lot, you know. Could devote that to my family, could devote that to working on something, I could devote that to whatever. And then there's one more thing. Oh yeah, not to mention I can actually get greater pay too as time progresses, right? Which is not so bad. And having a job, I could have health insurance and stuff. I mean, there's all kinds of things that are quite good benefits to working, but also having a home and a place to. Yeah, I mean that's pretty much it. It's like if you're working, you have an income, and you don't have any real like payments to make, because it's everything's set up on the land, the house. You have food there. I mean, you got everything you need. I mean, you're gonna have all the money you need, and then should be good to go. Yeah, could pretty much afford anything. Give the kids whatever if they want a fund. I could put a fund together for them, and I could just spend all my time with my family, and the kids and then my wife. Like, that sounds so good. That sounds so good. It's like, why, and not that I would eventually want to quit my job, but maybe. I mean, it depends, right? I mean, if I make enough where I can actually invest it and make more than the make of the job, it's like, well, if you're self-sufficient and your investments make a lot of money, then you could just live with your family, have your kids, and take care of your family. So yeah, I'm pushing for that, right? So bottom line, not to ramble too much here. Let's update on that. I spoke to my employer, spoke to a recruiter also who pointed me in the direction there's maybe another job available out there. So I'm thinking I might interview there, give it a shot. It looks interesting. They said they're open to remote work, so it's possible. There is, yeah. So there's two opportunities right there. Oh no, I don't know if I mentioned that. Yeah, I spoke to my employer. Right, there's actually a job on another team that's available, which I might be able to basically I would apply there. I don't know. I kind of have to go talk to the folks, talk to a bunch of people, and see what I can do. But if I can switch to another team, which there is a spot open, which I'm fairly confident. I'm a little scared because the specific sort of technology, the language that they were describing is actually one of the few languages that I've spent not a lot of time working with. I've worked with a lot of different technologies and languages, but there's the one language that I really haven't spent a lot of time with is the one that they have a lot of code in. So I'm a little bit concerned, but it shouldn't be too bad in theory. In theory, it shouldn't be that bad because of the languages. They have a lot of similar constructs, and a lot of it shouldn't be too hard to sort of figure out what I need to figure out in order to be successful. But and again, I can always just study on the side. Like once I'm done with this Clojure stuff, I'll just switch right over to those things. What's it getting at? Yeah. So there's another position, another team that I believe I may be able to obtain that position, and then work remotely there. And so that's another option. So there's at least two options already on the table, which is great. I haven't even really started looking on my own volition beyond like just what's immediately around me, right? Like I could sort of spread my or to see what's out there. Right? There's a lot of stuff I could try for, and then so that's an update on sort of what's going on, and as far as like business goes with the business. I mean, I'm just kind of mostly just there to like help out. I'm not really too involved in like the more long-term goals. Although I'm somewhat cognizant, I'm not like super like, I guess, interested in all that. Largely because it's not really the role that I'm in. It's not really like I'm managing some things, but I'm what do you call that? I am most of what I do is just making sure things go smoothly. Things that are sort of already set up, or not already set up, but things are sort of plans that are already in motion. Kind of just helping make sure that they go smoothly. Yeah, there was an interesting event today that was like, we caught it very quickly. There was one thing sort of went wrong and was sort of immediately addressed, which I thought I was proud. Not that I'm proud of it, but I kind of felt like, all right, like I'm useful. I don't always feel useful, but when I do, it feels good. Anyway, yeah, like if I wasn't there for that event, that could have been like in the past. I remember in the past these events happening, and they were like really, really a lot of chaos, typically. Although, well, anyway, I'll just say today I was useful. So, right, okay, that's fine. I mean, that's enough. That's enough of an update. I mean, it's on my mind, man. I'm like, like I gotta do it, man. Like it's just really, you gotta push. If you want the life you want, you gotta push for it. You gotta create it. I think the big insight is the risks, right? Like, gotta push for, even though, like, yeah, when you're young, you should take risks, but like, I'm not really young anymore. I'm not really in that phase. I'm not, when I was 18 maybe, but I'm not 18 anymore. I'm 27. Like, I'm way past like the, take risks and make your dreams come true phase. Like, it didn't work out. That's it. Like, whatever risks I took didn't pan out. That's it. Now it's time to figure out how to find something secure and have a family before I age into oblivion. Yeah, if I want that, which it would be really tragic life if I didn't have children. I think so. Tragic existence. So anyway, now the thing is, what are we missing here? What do we need to do? What to think about? Oh yeah, okay. So to update on what's going on here. So basically, this problem, to come back to it, this is an interesting problem, man. This is an interesting problem. So yeah, all right. We're gonna come back to this later. I'm gonna skip over it for the time being. But I just want to quickly review something. So with these Karnaugh maps, effectively what this question is asking us to do is to write an algorithm that would programmatically solve the problem that K-maps were built to help solve. And the thing that's interesting about this is actually, right, there's Veach charts, Marquand diagrams, Harvard minimizing chart. There's a bunch of stuff here. What all this is used for is to minimize circuits, right? Circuit minimization in Boolean algebra. That's what Karnaugh maps are intended to solve. And the idea is that you have sort of a very large circuit that has a whole lot of pieces to it. And what you want to do is you want to minimize it. So you want to have
you want to use as few, you want to have the equivalent sort of logical circuit that you've got, the equivalent one, but has as few pieces as required, right? So you could replace as many pieces as you want, remove pieces, whatever you want to do, but it's got to be this. It's got to be logically equivalent, but with as little hardware as possible, right? So it has a very obvious kind of like real world implication that if you could solve this problem, then you could spend as little money as possible on the hardware and on the cost of actually building your circuits. As it turns out, though, and so that's why there was a lot of different attempts. You saw these different charts and things. As it turns out, though, this is an extremely difficult problem, and if we quickly take a look, we'll see. So Boolean algebra circuit minimization is the problem of obtaining the smallest logic circuit represents a given Boolean function or truth table. For the case when the Boolean function is specified by a circuit, that is, we want to find an equivalent circuit of minimum size possible. The unbounded circuit minimization problem was long conjectured to be. This is a form of NP. This isn't just NP. This is even worse than NP. I'll explain what it is, but it's basically probably only exponential time algorithms, if not worse. I'll explain what it is. And then it was finally proved in 2008 that it is indeed non-polynomial. But there are effective heuristics, so Karnaugh maps are useful, and the Quine-McCluskey algorithm. So these are heuristics. So they don't necessarily give you the optimal. Well, heuristics actually, I don't know if actually Karnaugh map is not so much a heuristic as it is just a method, because I don't know how well you can scale Karnaugh maps realistically, because you actually use your eyes to solve the problem, which is like kind of wild, right? Like something kind of amazing about humans is that the human brain seems to have an optimal kind of heuristic for pattern recognition. And I guess we'll just say God gave us that gift. We can solve incredibly difficult problems very efficiently on a relatively small scale. Although, I mean, I guess you could say you could do this. I guess you could also probably do this, on a large scale, a small scale too, with a computer. But it seems to be this pattern recognition thing that your brain does. You can solve this very, very efficiently. This problem just with your eyes, and that's what Karnaugh maps do. And then the Quine-McCluskey algorithm might be like a proper heuristic, where it doesn't give you the exactly correct answer, but gives you a close enough answer, something like that. That's with a lot of optimization problems and minimization problems, where you want like the exact optimal best possible kind of thing. A lot of those problems end up being exceedingly difficult. Like they become like and non-polynomial. But if you just kind of relax the condition to be like, instead of absolutely minimal, to make it like, close to minimal, like, reasonably minimal, then you can use heuristics that are a lot faster. That's often the case, and that's, I think, what the Quine-McCluskey algorithm is. It just kind of is like reasonably reasonably minimal is sort of what you're looking for, and it's, I guess, it's sort of a lot. I guess it's faster than trying to solve this non-polynomial algorithm. Let me show you quickly what this means. This sum p sub 2 complete, this thing, polynomial hierarchy. So multiple equivalent definitions, class of the polynomial hierarchy. Oracle definition of the polynomial hierarchy: define delta, which is sigma, which is p, which is I forget what this is called. I think this is, what is this? This multiplication symbol Greek pi. Oh, it's capital pi. Okay, got it. Yeah, it's capital pi, capital sigma, capital delta, sub-zero, superset, super p sub-zero, we'll call it. Right, these are all sort of the set of decision problems solved in polynomial time. So these are polynomial decision problems. Then and you can define recursively. This is delta p sub I plus 1 is going to be p raised to sigma p sub I. I'm not sure what that means. And then sigma p sub I plus 1 is np raised to the sigma p sub I, and then pi p sub I plus 1 is going to be the co-np. I'm not sure what co-np means. Raised to the, looks like pi raised to the super p sub I, where p super a is the set of decision problems solvable in polynomial time by a Turing machine, augmented by an oracle for some complete problem in class A. The classes np and co-np sigma a or super a defined analogously. For example, sigma sub 1 super p is equal to np, and pi super p sub 1 is co-np, and delta sub 2 super p is p super np. Is the class of problems solvable in polynomial time with an oracle for some np complete problem? Interesting. I don't really understand what they mean by oracle here. For the existential universal definition of the polynomial hierarchy, let L be this language. I don't really understand what these things mean. I don't know what there's a lot of stuff here that I'm kind of missing. I just don't know. Like, I don't know what the co-np is supposed to mean. But somewhere here we can show or find and see that this, basically somewhere here we find that the sigma sub 2 super p is more difficult than np. That's kind of the bottom line. It's non-polynomial. All right, so this is np, and then here's the next class. So it's a whole sort of class more difficult than it's in a whole different class of non-polynomial time algorithms, but different complexity class in the hierarchy. I don't really know how to express this exactly in English, but it's an analog of the exponential hierarchy and arithmetical hierarchy. Interesting. It's known that pH is contained within P space, but it's not known whether two classes are equal. Useful reformulation of this problem is that pH equals P space. If and only if second order logic over finite structures gains no additional power from the addition of a transitive closure operator. All right, I don't know. I'm kind of like floundering a bit here, but basically that's the bottom line, is that we've got this non-polynomial complexity class up here, which is where this resides. So what that implies is that we're not going to find an efficient, simple algorithm to solve what they're asking for here anytime soon. That's like the bottom line. So I realize this is a very long-winded way of suggesting that this problem is going to take me either a lot of time or if I brute force it, it won't take me that much time, but even the brute force algorithm is going to be a little more complicated than your average brute force algorithm, because it's in a whole complexity category beyond just merely non-polynomial. It's actually in this sigma sub 2 super p complete complexity class, which is quite difficult to solve efficiently. That being said,
Yeah, and the algorithm that I ended up coming up with was extremely slow. Was unfortunately quite slow. I think the site will still accept the problem of the solution, but it was a very slow algorithm, and I was kind of sad about it. And that's why we're going to come back to this one. We're going to come back to this later, another time. We'll have the answer, and I'll review it. But yeah, it's a bit of a doozy. It's a bit of a doozy. So we'll come back to that. Bottom line, we'll come back. We'll come back to it. Very interesting question. Very interesting problem. Definitely, definitely glad that they asked it. Even though, like I said, these hard problems are taking me like freaking forever to get through. There's just so much involved, you know. But yeah, there you go. Circuit minimization. That's basically what this boils down to. We get to learn a little bit, get a solid example, a full understanding of a different complexity class of problems. That's kind of neat. So anyway, that's also those different the Veach diagrams, and the Marquand diagrams, and all that stuff. Those are all just heuristics to solve this problem. This is an exceedingly difficult problem. Which is pretty funny because the problem itself is like kind of simple to understand as a statement. It's just take a circuit and then find an equivalent circuit that takes a lot fewer pieces, as few pieces as possible to get the same circuit. It's like, oh, one would at first glance think like that's pretty simple. No, not at all. Not even remotely. Not even remotely. It's kind of interesting. So now, tricky card games. Okay. In trick-taking card games, such as bridge, spades, or hearts, cards are played in groups known as quote-unquote tricks. Each player plays a single card. In order, the first player is said to quote-unquote lead to the trick. After all players have played, one card is said to have quote-unquote won the trick. How the winner is determined will vary by game, but generally the winner is the highest card played in the suit that was led. Sometimes, again, varying by game. A particular suit will be designated quote-unquote trump, meaning that its cards are more powerful than any others. If there is a trump suit and any trumps are played, then the highest trump wins regardless of what was led. Your goal is to devise a function that can determine which of a number of cards has won a trick. You should accept a trump suit and return a function winner. The winner will be called on a sequence of cards and should return the one which wins the trick. Cards will be represented in the format returned by problem 128. Recognize the playing cards. A hash map of suit and numeric rank. Cards of the larger rank are stronger. So this is a pretty. It sounds kind of complicated what they're describing here at first. It took me a while to kind of parse this and understand what they want, but it's just pretty straightforward. I'll explain shortly. Let me just set up this scaffolding here. So call it scaffolding. So we want tricky cards, and we want, what is this? Trick taking, yeah, tricky cards. Take as input a. So this is very interesting because we're going to actually return a function. So we're going to return trump suit, right, as the input, and let's use a let. And let's, how many of these do we need? We got 1, 2, 3. All right, here we go. Let's take a look at the, oh, hello. 1, 2, and 3. Okay. And we're going to print each of these. think it's this one, yeah. And each of these are going to get their... Okay. And then we're also going to tricky cards here. All right. Now, what this is asking for, it's pretty simple. The way it works is you're given the first card, you're given a set of cards. The cards are represented by a hash map of a suit and a rank. So you see how there's a suit and then the keyword for, you know, club, spade, diamond, what have you. And then there's an integer for the rank, right? Which I think is 0 through 12, I want to say 0 through 12 or 1 through, yeah, I think it's 0 through 12 for the ranks. So you're given an array of these cards that have this kind of setup, right? This hash map, and the first card in the array is going to set the quote-unquote trick. It's called lead the trick, they call it. So that will set the suit. If no other cards have the same suit, then that card is the one you're going to return as the winner, right? All those are the only cards that matter are the ones of that suit. So any other cards that you see in the array, like for instance for instance here a spade is set, then you have a club, we ignore the club, we return spade and rank 2, right? Here we have a club that has a higher value, so we return the club with a higher value, right? So the only suit that we care about is the initial suit, and then all the ranks that we see afterwards, we're going to take the maximum rank of the same suit and ignore the cards that have a different suit. If there's a trump card, that's if there's no trump card here. If there's a trump card, then that card, it'll tell you, right? If we call our function on a club as the trump card, or we call it on heart as the trump card, the trump card is quote unquote stronger than all the other cards in the sense that any card we see with the trump card suit is not only stronger than the lead suit that we're interested in, but it's actually, yeah, it doesn't matter what the rank is for the lead suit. This also takes priority over the lead suit as well. So then we say, okay, if we see anything with a trump suit, then we take the card of the highest rank there. So it's kind of interesting. Basically, you end up considering, simple way to do this, and probably how I'll end up doing is maintaining the two suits and then just updating as cards come across the highest rank for those particular suits, and then checking, if we saw any cards of the trump, then take that card. Otherwise, take the quote-unquote trick suit card. Yeah, and you just keep updating those two variables as you loop through the cards that you're given. Pretty simple. I think that ought to do it. So we'll go with that. And we'll have obviously a function that this returns a function that does what we were just describing. So what we want to do is return a function. And the function is going to take these things that we're interested in. And this is going to be cards as input. And, just ensure that this is sequential. Right. Now what we've got to do is kind of want to reduce over
reducing function. Reduce over, I guess we'll just do a vector of 2 cards. And we'll say cards. Right. And we can how do I do this? Not sure about this. I kind of want to say like, I kind of want to set the 2 suits up front here. Huh. I mean, we already have the trump suit. But the one we don't have initially is which we can get initially. We'll just say lead suit is if first of cards, then take first of cards of suit, otherwise nil. And then we'll say this is a function. We're going to have, now we want to destructure. Now this is kind of interesting because we're going to destructure a map. I don't know, how do you destructure a map in Clojure? Can we do that? Map. Strings by character. Associative destructuring, yeah, that's what I want. Without destructuring, yeah, that's not what I want. I want to use the destructure, use the map destructuring. Name, location, client. Okay, oh, cool. So we can. Now the problem is I don't know how to destructure within a function. Oh, no, that works fine. No, that works. No, take it back. I take it back. We're fine. You can just do it like so, just like so. Category, client. We'll call it sort of suit, and now, yeah, that should be fine. So suit, and the other one is rank. Okay, there we go. So that'll destructure. Nice. I don't do that too often. I like that. All right. So these we'll get the suit and rank from each of the cards, and then ret is going to be call this lead card and trump card, which we also will destructure both of these to the lead suit and so look at that. Isn't that beautiful? Just loads and loads of destructuring going on here. Save ourselves a whole lot of, indexing into and out of these cards as we're looping through them, as we're operating through them, or working through them. So we have suit. So we're going to have the lead suit, or lead, or L suit, we'll call it L rank. And then this is the trump suit, trump rank. All right, and we can even just quickly put this in such a way. Oh, no.
All right. So now we have our reducing function. We would say if. So now we want to return, right? Say, well, we can use a let here also. I mean, yeah, could use a let here also. Anyway, call it something like this. Else suit is going to be if, or not else suit, L rank. It's going to be updated to if suit is else suit. Then we say L rank is going to be the maximum of L rank and record rank, right? Otherwise it doesn't change. Something like this is what we want. And then we've got T rank, same thing. T suit, T rank, T rank. And then we just return these things as they were. Suit, L suit, rank, L rank. I think this is what we want. Just real simple. Right? That's simple. You know? Alright, see how we do. How to do today? How to do today? False, false, false. Nice. 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 Whew. All right. Let's see what we do. What do we expect? Expect club rank 9. We got suit nil rank. Nice. Nice. Oh. Okay. Well. well. I mean, there's a couple things are missing here. Okay. There are a couple of things that we're missing here. Go into all that shortly. Cards. Let's also just go ahead and simplify things a bit here. Let's see. Suit, club, rank 4. What am I looking at here? Takes this function cards. Let's actually just do, yeah, let's just do one at a time. Let's do one at a time here. Oh. So I print cards, and that should be a vector. It is. 2 cards. Club 4, rank 4, club rank 9. Yeah, okay, that's fine. And then okay, let's print the lead suit. And let's also print trump suit. So I think this is supposed to be lead suit, and this is supposed to be trump suit. That might be part of the issue here. Nice, the syntax error, great. Okay, so club nil, lead suit, trump suit, cards, reduction, syntax error, compiling. What's the problem? Excuse me. What's the issue? Null pointer exception. Who, what, when, where, and why? Has this become bound here? It's supposed to. Where's the null pointer exception happening though? I mean, this is what I changed, right? Could we just do 0 or something? Test. I don't know. Let's see how we do here. Oh, of course. Of course. Where's the null pointer exception though? Why does that happen? L rank, I guess. Because I guess these are nil to begin with. Max of nil. Really? Can I not do that? Really? Try it. So, I mean, Wow, no kidding. I mean, okay, fair enough. Guess I'll have to remember that. Like, wait a minute here. I mean, we could do this, I guess. Kind of need to go back to this though. Okay. And want to do one more detail, which is map int to that. All right, how we do here? How do we do here? Oh, no. What do we get? What do we get? Let's take a look. Nope. What? What do you mean? Can I not? Wait a second. Wait a second. I think I know what's happening here. Nice. I mean, you know, that's fine. I think I know what to do. It's pretty funny, but you're kidding. How? This is ridiculous. This is ridiculous. All right. I almost can't believe the situation I find myself in right now. This is, this is pretty funny. This bad, I'm going. It's almost like all right, we can do this, I guess. No, it's not. You gotta have an and here, I think. Not nil. If the L rank is nil. No. So if this suit, if it's not the suit you're looking for, then you definitely go here. If it is the suit, then this has to be not nil in order to go here. But if it is the suit and L is nil, then you'll just go right to rank. So there's actually 3 different cases to consider here, which is why I want to use the cons. Yeah, that's what I'm thinking. Okay. Okay. Suppose we're looking at No, man. This pre. No. 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 It's not a. No. Wrong. If. No. 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 Okay. Hold on. Hold on. Hold on. I don't know. We're going crazy here. All right. I think I got it. If we're not equal, then we're going to take whatever's there. If we are equal, we're going to say nil of L rank. If this is nil, then we just take L rank. Or we just take rank, rather. Otherwise, we're a happy fellow. Okay, there we go. There are three, yeah. Here's how you can set it up. So you could say, if this suit is not the lead suit, then whatever rank we currently have, we continue to keep it, whether it be nil or otherwise. If that rank is nil, and we are the lead suit, then we want to compare, then we want to take the new rank, right? Because we don't even compare it, because we get a null pointer exception. Otherwise, we want to take the larger of these two, the better. Okay, that makes some sense. That makes some sense. So same thing here, except for Trump suit and T rank. I was not expecting this to take so much time as well. I thought I was going to breeze right past this one. All right, let's give that a shot. Okay. How do we do? How do we do? Also, we're going to go to bed shortly. Whew. Okay. Club 4, rank 9, nil, rank 9, nil, rank nil. What? Excuse me. Excuse me. 1, 2, 3. Try again. We go again. And we go again. So printing. Right, so suit nil, rank 9, suit nil, rank 9, nil. This doesn't make any sense. This is the lead suit if... Come on, man. Okay, suit, rank. Can we print? It's L rank, T rank, L suit, L rank. So, this should be the lead suit, and this should be the Trump suit. That doesn't change. Okay, that works. Yeah, that's fine. And then we just return down here. We just get a do destructure again. This one, right? And then you say if Trump suit is nil, And then you're going to return, no, actually you want to say, it really should be T rank. If T rank is nil, then you return the this guy. You want suit L suit and rank L rank. This ended up being way more involved than I thought it would be. Otherwise, you want the other one. You want the T suit L suit L T rank. There we go. Give that a shot. See what we get there. See how we do. Nice. What? Excuse me? Don't have Trump rank, huh? T rank should be. It's over 9,000. Trump's rank. Just kidding. Okay, I think this is what we want. So, oh, yeah, no, okay. So, all right. Let's try now. Just get one of these. True. Sweet. And one more. Uno más. True. Nice. All right, got him. Sweet. Yeah, it took me a lot longer than I was expecting. Definitely a lot longer than I was expecting. But we got one of them at least. It took a while. Could look at the solutions here. Or go back and try the one you gave up on. Go back and try the one you gave up on. How about that? Oh my goodness, look at this. 42 lines of code. 8 lines of code. Holy guacamole. Oh, but he used a... Yeah, I mean, I guess you could do it that way too. Wow. Yeah, I don't like these approaches. You know, they don't really account for... they don't really leave room to account for like faulty input, bad inputs. You know. Wow. Winner hands, let's suit if Trump suit, keyword, and take first of this hands, Trump suit. Sort by rank, filter. I didn't think of that. This is also somewhat incorrect. Yeah, I mean, these are, like, they don't, like I said, they don't really leave room for faulty input, or at least even where you can add code for faulty input. I mean, I don't know. I shouldn't say that. Maybe probably you could do this better this way, and then also add stuff like to handle different cases. But the problem you have here is if you have the Trump suit, but you don't have any cards of the Trump suit there, this fails. Right? Like, you can actually break this code because this is only looking for this particular suit. Just gotta be the Trump suit. So if you define the Trump suit, but then you don't have any Trump cards here, even though there is a Trump suit, there could, in theory, be no cards that suit and then you'd have to take one of the lead suits, right? This code would fail in that case. I think these do the same thing, these two. These both would fail for that reason. Although this, yeah, also same issue. Yeah, same issue. I think this one probably has the same problem too. This one might be one of the only ones that that handles both possibilities. I don't know if it does or not. I can think about it. Let's just read it. Keys, suit as cards. That's confusing, but okay. It's just keys. All right, fine. You're gonna have this condition P, which is a special kind of conditional, which uses like a function. So you'll apply this equals to this. I think does it work? It's this equals this, right? And then you'll do that if it's true. So this is the suit of this percentage, which is this function. This is actually an anonymous function. So it takes something which it's going to get. It's going to get the cards, I think. Function as cards. Actually seems to return. I don't know what this is doing. Where is this being used? This is a function that seems like it's going to call. It's going to use this function, this lambda function, as the second argument. So you sort, right, okay, so you sort by cards. So this is sorting by this function. Very interesting. Okay, so you sort the cards with this function, and this says, okay, get the suit of your card. If that suit is the trump card, do this. If it's the suit, which is defined here, what is this? I guess this is destructuring of the cards. Now this is really confusing. This looks like you get this function as cards. This gets destructured into a array of keys and a suit. That's extremely confusing. Forgot you could use that. Oh, right, yeah, okay, of course, duh. It's a set of keys, and then you get name, location, description. I learned about this too, and I completely forgot about it. You could destructure this way too, but you could destructure using this inside of, so you get the name key, and you'll actually get you just print this directly, right? That's pretty cool. Duh. Okay, that's my mistake. I forgot you could do that. Right, so you get the suit from cards, destructure suit, associative destructuring using keys, right? Makes sense. Okay, got it. So this, but on top of it, the problem with this is if you give it a bunch of cards, like if I take this, right, just do this.
All right, we do this. If we do this, do the following. All right, test. Let's just call it testing. Test me. Get this function. And if we call this function, all right, test me of. Just call it nil. All right, give us a shot. Club. Okay, we get these keys as cards. And what happens if we print cards? Because that's the thing that's kind of got me wondering, what is this doing exactly? Looks like it's just getting from the first. Oh, that is very interesting. So it looks like you're gonna take arguments. The single argument is destructured as follows. It looks like you don't actually destructure the entire thing, because you could do. What if you did this? Keys of sweet. What if you did that? What happens if you do that? That won't work, right? That doesn't do anything. How? What happens if I change that to heart? Or change this to heart? Heart. That's what I thought might happen. Takes the last one. Just double check that. Oh, no, it takes the first one. What is going on here? What is this doing? This is so weird. Huh? What does this do? What does this even do? What's going on? What am I looking at here? What? I get this, right? This destructured the whole thing as cards, right? So we get both cards. Okay, that's fine. But this part, why is this? This is a, so it's a map. Okay. So I think the issue might even be, what if you did this? Keys, suit, or how about this one? Suit 2 of suit. Right? What does that give us? The second suit. We'll try to get that. We're learning about destructuring here. Oh, okay. I think I understand. So what we ended up doing is we said we're going to destructure to this and this. We're going to take the first element is going to be destructured into using associative destructuring. The second element, yet another associative destructuring. The rest of everything else, including the first two, drop into cards. And that's how we understand, how we are to understand this fanciful destructuring that was presented to us. Very interesting. So he gets the first suit here.
Now it says, okay, check the suit against this value, right? Get the suit from this card. We're going to sort using this conditional expression that says, all right, if we're a trump suit, then we get the rank and subtract from a negative 100. So the trump has super low ranking. The regular suit, we subtract whatever the rank is that we're looking at here. And finally, anything else is 0. If we're not trump suit or suit, we're always 0. Let me take the first. So that means 0 is always greater than these negative numbers, and the most negative thing will become all the way to the left. So this actually handles the case where you are given a trump suit, but none of the cards have the trump suit in there. So this clever approach handles that. Notice that these are also somewhat inefficient. These are not linear time because there's sorting. I didn't do any sorting. You may notice that. Very deliberately did not do any sorting. Used a simple reduction and just updated the correct values as we went. But given the there we go. This max key is what I should have used. This is kind of what I should have done. This is more like it, something like this. I could have destructured nicely here, and then instead of using condition P, you could have used apply max key, something like that, and could have used as the key this function instead of sorting. Yeah, that would have been better. Why I didn't do that, I don't know. Kind of didn't think of it, I guess. Probably should have. But yeah, would ideally want my code to look more like this, not so much like this. I think I would need more practice. I think it has more to do with the problem itself, though. Like I'm kind of just coding up the first thing that comes to mind, just trying to code it. I think if I had more time to just kind of sit and think about what I could do, then and even had other input from other people, how to improve it, then I would do that like slowly over time. I think a lot of this probably comes from experience. You kind of think about, how you could sort using a condition or using or using a what do they call that? A key of some kind. Yeah. Can get the suit using destructuring, and then can get the. Although this is kind of a tricky thing. This is kind of a hack. I probably wouldn't think to use this. I would, I think, say like. Actually, how would I do that? I probably want to get like the max rank of the suit cards first as like a variable, and then just add that here. Write the same code and just add that here. That would work, or subtract it, whatever it is. Interesting. Yeah, anyway. All right, moving on. Go to the next one. This one's kind of easy. This is, you can just take I think you can just do this right now. This is a dot product, right? If you're familiar with dot product, you multiply this and this, this and this, this and this, and then you summate the whole thing. So it looks something like, so you can do, to get the sum, you do map plus over the two collections. So let's just do collections. And we're gonna map a sum, not sum,
multiplication over the collections, right? Apply. And then we're going to sum the results at the end. I think that's what we want. How's that work? Yeah, done. Right, so take each of these collections, map. What the map's going to do, it's going to apply a function with each of these as the arguments, and then so you can multiply, right, with a map, and then you can just add the results. Which this apply will just take all these results as a sequence and then try to make them arguments of this function. So yeah, I want to do it. That one's like a lot easier than the other problems. This one's interesting, this oscillate. Write an oscillating iterate function that takes an initial value and a variable number of functions. It should return a lazy sequence of the functions applied to the value in the order, restarting from the first function after it hits the end. So you're going to take this initial value, apply this function, then to the result of that, which is 3, apply this function. So it goes 3.0, and then apply this, goes back to 3, and then this goes back to 3.0, and it'll keep iterating indefinitely, and you take however many you want from that lazy sequence. So pretty cool. Increment, decrement, increment, decrement, increment. All right, just keep cycling. There's actually a cycle sequence, which is kind of cool. Like you can make this cyclical by applying cycle to these functions. So that's kind of neat. The only tricky part is you need to iterate and apply the next value from that sequence, which is kind of tricky. I'm wondering if you can do cycle, no. I kind of want to like combine these lazy sequences, like somehow clever. I want to cleverly use the cycle sort of method or function here to cycle through the functions. I guess what you can do is you cycle on the sequence, and then you want to iterate, which is going to repeatedly apply a function. And I guess that function returns, each time you call it, returns the next function. It's like sort of a cycle. No, it doesn't seem particularly good. Also, thinking reductions maybe is what you want. No, it's not really reductions either.
I'm thinking like you could take a portion of the cyclical sequence and then just recalculate, but that seems really bad. You kind of want to calculate one after the next. You don't really want to like do quadratic time complexity for no reason, which would be like enumerating all of the functions that you need and then applying them from the start to the point that you're interested in, just to make it sort of quote unquote functional. It seems bad. I guess I'll end stream here and just kind of ponder this, but I don't really have a good solution yet. How to do this? How I might do this with there's got to be a way to do this that I'm not thinking of. There's got to be a way to do this that, what do? Excuse me. I want to, oh no, man. Excuse me. I think reductions is what we want. The problem with reductions, though, is that we're applying a different function at each step, which makes it kind of amorphous, which I don't think we can reasonably do. Excuse me. Is there like a next in Clojure? I guess rest. I don't know if reductions is what we want. It's not really interleave. What could it be? What is it? It's like reductions, but something else. Excuse me. Oh. You just reduce reductions over the cycle. Oh. Duh. That's really simple. Okay. Okay. All right. So we take initial value, and functions. All right. And now we're gonna create cycle as functions. Okay, ready for this? It's a collection. So actually we do want to do cycle functions, reductions, And we're going to take this initial value, and we're going to use this guy, which takes 2, right? The initial value is apply this function. Cycle functions, reductions. Does this work? Hey, check me out. Boom. Easy. Hey. Nice. Nice. I knew there was something in there. I was like, this has gotta be an easy way to do this. There's gotta be a way to do this. This is clever. Alright, I was gonna go, but let's go to the next one. I think I like that solution. I don't even want to look at anyone else's solutions. Alright, that was a good one. For the win elementary. Clojure's 4 macro is a tremendously versatile mechanism for producing the sequence based on some other sequences. It can take some time to understand how to use it properly, but that investment will be paid back with clear, concise, and sequence wrangling later. With that in mind, read over these 4 expressions and try to see how each of them produces the same result. Interesting. All right, we'll come back to this. So, thanks for watching. Talk to you all soon. Have a good rest of your night. And yeah, I mean, code wrangling, I definitely could use some practice. As you can tell, some of these solutions that I've come up with are like 50 lines of code when they could be 10 lines of code. I think I just need more practice, that's all. Which is fine. I mean, I already did get a lot of practice with these problems, but I think part of the issue is like I spent a lot of time messing around with like the actual solutions to some of these problems, because some of these are, like I said, like one of those problems, it was a greater than NP complete, you know, in terms of a complexity class harder than NP. So, or seeming could be, or one complexity class above NP, so NP complete. So some of these are kind of tricky. Could end up spending a lot more time thinking about the problem than you do like the mechanics of how to solve it. And then even when you have a way to solve it, then you're just not really thinking about the mechanics of it, but you're just thinking like I don't know, just solve it. Is my logic even correct? And then mechanically you can try to sort it out later. Yeah, I mean, I think part of it is like practice. Another one is like seeing other people's code, how they do it. It gives me ideas. Kind of got to go between those. Yeah, just practice. I think that's really what it comes down to, is lots of practice. HackerRank, you can use Clojure, so I can probably solve some HackerRank problems as well in Clojure. Although I really want to focus on, I think, interviewing, than more so than like solving coding questions endlessly, right? Like it just takes a lot of time. And yeah, like I said, I need to find a wife and have kids and get some remote job and do that. It's gotta happen. Gotta do that. Yeah. All right. I'm gonna go. So thank you again for watching. Talk to you all soon. Have a good rest of your night. And yeah, take care. Take care.